From the dawn of humanity, we have gazed up at the night sky in wonder. The twinkling stars, the distant planets, and the vast expanse of the cosmos have always ignited our curiosity and imagination. We have long dreamed of exploring these celestial wonders, of venturing beyond our own planet and into the great unknown. Today, that dream is becoming a reality. With each passing year, we are pushing the boundaries of space exploration further and further. We have sent robotic probes to every planet in our solar system and beyond. We have landed humans on the moon, and now we are setting our sights on an even more ambitious goal, sending humans to Mars. The journey to Mars and beyond is a journey of discovery, a testament to human ingenuity and our unquenchable thirst for knowledge. It is a journey that promises to unlock some of the greatest secrets of the universe, and perhaps even reveal the existence of life beyond Earth. Buckle up, space enthusiasts, as we embark on an exhilarating adventure to explore the future of space exploration.
The year was 1957. The world watched in awe as a small metal sphere called Sputnik 1 soared into orbit, marking the beginning of the space age. This momentous event, orchestrated by the Soviet Union, ignited a fierce rivalry between superpowers and propelled humanity into a new era of exploration. The United States quickly followed suit, launching its own satellite, Explorer 1, just a few months later. The space race was on, and it would capture the imaginations of people around the globe for decades to come. The ultimate prize in this cosmic competition was the moon. In 1969, the United States achieved what many thought impossible. Apollo 11 touched down on the lunar surface, and Neil Armstrong uttered the immortal words, "That's one small step for man, one giant leap for mankind." The Apollo missions, a testament to human ambition and technological prowess, left an indelible mark on history. They inspired generations to dream big and reach for the stars.
Among all the celestial bodies in our solar system, Mars holds a special allure. It is a planet of striking contrasts, with towering volcanoes, vast canyons and polar ice caps. But more importantly, Mars is the most Earth-like planet we know of, with evidence of a watery past and the potential to harbor life. Mars and Earth share several similarities. Both planets have a similar day-night cycle, with a Martian day lasting just a bit longer than an Earth day. Mars also has seasons, although they are twice as long as Earth's due to its longer orbit around the Sun. The presence of water ice on Mars, both at the poles and beneath the surface, is particularly intriguing. Water is essential for life as we know it. The discovery of liquid water on Mars would be a game changer, significantly increasing the possibility of finding past or even present-day life. These factors, combined with its relative proximity to Earth, make Mars a prime target for exploration. It is the next logical step in our journey to understand our place in the cosmos. Before we can even contemplate sending humans to Mars, we must first learn as much as possible about this alien world. This is where robotic explorers come in. Over the past few decades, numerous spacecraft have been dispatched to Mars, acting as our eyes and ears on the Red Planet. One of the earliest successful missions was Mariner 4, which conducted the first flyby of Mars in 1965, sending back the first close-up images of the planet's surface. These images, though grainy by today's standards, revolutionized our understanding of Mars. They revealed a cratered and barren landscape, far different from the lush, Earth-like world some had imagined. Since then, a fleet of increasingly sophisticated robotic missions has followed in Mariner 4's footsteps. Orbiters like Mars Global Surveyor and Mars Reconnaissance Orbiter have mapped the planet in unprecedented detail, revealing its geological history and the presence of water ice. Landers like Viking 1 and 2, Pathfinder and Phoenix have touched down on the Martian surface, analyzing the soil, studying the atmosphere, and searching for signs of life. Section 5. The Curiosity Rover, a decade of discoveries. Among the robotic explorers that have graced the surface of Mars, the Curiosity rover stands out as a true marvel of engineering and a testament to human ingenuity. Since its dramatic landing in Gale Crater in 2012, Curiosity has been tirelessly roving the Martian landscape, sending back a treasure trove of data that has revolutionized our understanding of the Red Planet. Equipped with an array of sophisticated instruments, Curiosity is essentially a mobile laboratory. It can drill into rocks, analyze their composition, and even sniff the Martian atmosphere for clues about its past. One of Curiosity's most significant discoveries was finding evidence of an ancient lake in Gale Crater. The rover detected sediments that could only have been deposited in a lake environment, suggesting that Mars was once a much warmer and wetter place than it is today. This discovery has profound implications for the possibility of past life on Mars. Where there was water, there could have been life. Section 6. Perseverance, searching for ancient life. Building on the success of Curiosity, NASA's Perseverance rover is the latest robotic emissary to explore the Red Planet. Landing in Jezero Crater in 2021, Perseverance is tasked with an even more ambitious mission, searching for signs of ancient Martian life. Jezero Crater is thought to have once been a lake, making it a prime location to search for evidence of past life. Perseverance will scour the crater floor for biosignatures or chemical fingerprints left behind by ancient microbes. Perseverance is also equipped with a drilling system that will collect rock and soil samples. These samples will be cached on the Martian surface for a future mission to retrieve and return to Earth, where they can be analyzed in detail for signs of life. This sample return mission, a joint effort between NASA and the European Space Agency, would be the first time that Martian material has ever been brought back to Earth.
Section 7. The Human Journey to Mars, a giant leap for humanity. While robotic missions have provided invaluable insights into the Red Planet, there's a limit to what they can achieve. To truly unravel the mysteries of Mars, we need to send humans. The human journey to Mars is no longer a question of if, but when. Both government agencies like NASA and private companies like SpaceX are actively developing plans for human missions to Mars. These missions are incredibly complex and challenging, requiring technological advancements in spacecraft design, life support systems, and radiation protection. The challenges of sending humans to Mars are many, but the rewards are even greater. Imagine the awe-inspiring moment when the first human sets foot on Martian soil, marking a new chapter in human history. Imagine the scientific discoveries that await us as we explore this alien world firsthand, searching for signs of past or even present-day life.
Section 8. Overcoming the Challenges, a test of human ingenuity. The journey to Mars is fraught with challenges that will push the boundaries of human ingenuity and innovation. One of the most significant hurdles is the sheer distance between Earth and Mars. A one-way trip to Mars would take about 7 months, far longer than any human space mission to date. This extended travel time poses numerous risks to astronauts, including exposure to cosmic radiation, muscle and bone loss due to prolonged weightlessness, and the psychological effects of isolation and confinement. Another challenge is the harsh Martian environment. The atmosphere on Mars is extremely thin, offering little protection from harmful radiation from the sun. The average temperature on Mars is a frigid -63 degrees Celsius, and dust storms can engulf the entire planet, posing a significant hazard to both humans and equipment. However, these challenges are not insurmountable. Scientists and engineers are working tirelessly to develop innovative solutions, such as advanced propulsion systems to shorten travel times, radiation shielding to protect astronauts, and inflatable habitats that can be deployed on the Martian surface. Section 9. Artemis, Gateway to the Moon and Beyond. Before we embark on the grand adventure to Mars, NASA is taking a significant intermediary step with the Artemis program. This ambitious program aims to establish a sustainable presence on the Moon by the end of the decade, serving as a testing ground for technologies and operations that will be crucial for future missions to Mars and beyond. The Artemis program involves a series of missions, each building upon the previous one. Artemis 1, successfully launched in 2022, was an uncrewed test flight of NASA's powerful Space Launch System rocket and the Orion spacecraft, which will carry astronauts to the Moon and beyond. Artemis 2, slated for 2024, will be the first crewed mission of Orion, sending astronauts on a trip around the Moon. Artemis 3, the most highly anticipated mission, is scheduled to land the first woman and the first person of color on the lunar surface no earlier than 2025. This historic mission will mark the beginning of a new era of lunar exploration, as NASA aims to establish a permanent lunar outpost called Gateway in lunar orbit. This outpost will serve as a staging ground for future missions to the lunar surface and as a stepping stone for human exploration of deep space, including Mars.